I'm on? Okay, I'm live. All right, I'll get going. All right, so thanks for coming. My name is Shaun Smith. I lead product management and developer relations at Oracle Labs for the Graal products. And I'm going to talk about some practical tips for hardening Java applications. So you're here in London, right? So when you cross the street, I'm going to give you a bit of an anecdote, something that happened to me. But we all have a certain sense of self-preservation, right? So when you cross the street, you look left, you look right. In London, they paint it on the streets for the tourists who don't know which way to look, right? But children don't look both ways, right? We all know this. If we've had children, we know they don't look. And it's because until about the age of 9, you don't have that sense of danger, right? Like you're invulnerable until about the age of 9. You just don't look. So parents have to basically hold your hand, when they cross the street. So we need that, right? So after 9, you develop that sense of danger, self-preservation, that you're not immortal, that you have to keep your eyes open, right? So this is kind of the fundamental concept or topic of the talk today, which is basically being aware of vulnerabilities. Now, I became really aware of this when I had something happen to me. So I was carrying a box for my daughter, some big heavy box. I think it was an IKEA box I was returning. I went outside onto my driveway and slipped on some black ice and hit my head in the ground. And then I remember being sort of stunned, dazed. I stumble into the house. Next thing you know, I'm sitting in the emergency room. I don't know how I got there. I was just sitting there with my wife, and they're like, "Oh, you're coming out of this?" I'm like, "What happened?" She goes, "Well, you were perseverating." I'm like, "What's that?" She goes, "Well, you kept repeating again and again, I think I hit my head. I think I hit my head." Now, she drove me to the hospital, which is very close, and it turns out even with a blow to the head, I'm a bit of a pain because I was giving her backseat driving instructions on the way, like, "Oh, turn here, turn there." But I remember none of this, right? All I remember is, I came to, they gave me scans, you're fine, right? Go home, watch out for concussion, but I had no problems. But at that point, I was suddenly aware, like I had been not before, of my vulnerability, right? So, we wear helmets when you're doing dangerous things, right? You ride a horse, you go cross-country skiing, or you go skiing, downhill skiing, you do dangerous things. I had this feeling that I should be wearing a helmet all the time, like 24/7, because I really need this head, right? It's really vulnerable. And I just fell down, hit my head. It wasn't like crossing the street. I was just suddenly I was vulnerable. I thought I need to encase myself in a pseudo armor because I can get hurt really easily, right? And obviously I'm not wearing a helmet today. I got over it. It fades back into the background of just watch out for yourself. But things can happen, right? Dangerous things can happen to you. And so this sort of takes us to hardening, right? I tried to harden my head. That's how I was thinking about this. But that's actually the wrong thing. I wasn't hardening my head at all. So hardening in software is actually not making things harder or shelling or putting a shell around them or a wall around them. It's actually about taking things out. It's removing your surface of vulnerability. So taking things away rather than making things more secure in some sense, right? Having less to attack is hardening. And of course, Wikipedia is always right. So this is where I get my definition from. So removing software components from your application that you don't need, removing services from your systems you don't need, this will improve your security stance because it'll reduce your surface or attack surface. So if I sort of give you a context of you got your application, all its dependencies, the JDK has 4,000 classes in it that are there with you. There's a lot of C++ code in the JVM that's running. You've got operating system, all those packages that your application deployed running on top of. And then nowadays, you even have cloud platforms, all of which also provide a whole set of services and things that are possibly exposed by your application or relied upon by your application. All of these are things you need to worry about. Now, my initial thinking of hardening was I need to build these walls, right? I need to strengthen the boundaries between these layers, and that's actually not what we're going to do, right? So hardening is really more like this, which is I need to shrink this down. I need to throw out stuff that we don't need, right? So this is basically a what's the tidying woman from Japan? It's Marie Kondo. It's a Marie Kondo approach, right? Throw out only what brings you joy or sparks joy, right? Throw out all the stuff you don't need, and this is the focus of hardening. So. Marie Kondo, yeah. So to know what you've got, though, you need a software bill of materials. And this is becoming much more talked about topic, right? So SBOMs. It tells you what's in your application. Or conversely, you will tell people what's in your application, right? So we need to have an SBOM so we can talk about whether we're getting rid of things or not, what's in our application. And you can get an SBOM for your own application. So you can actually generate an SBOM if you're building at home, at work, with Maven or Gradle. You can actually add this Maven or this plugin from CycloneDX to your application, and it'll spit out actually a list of all the components in your application. So when you give it to your downstream consumers, they can get an idea of what you're providing to them and whether they're concerned with those components. If you don't provide someone with a software bill of materials, or you don't generate one, you can actually reverse engineer one. So SIFT is one program, for example, that's available. There's a commercial version, there's an open source version of SIFT, which will examine container images. It can look at files, zip files, Java applications, jars, and try and extract and give you the list of components that are inside. And why you want to do that is you want to know what components you have so you can determine, is there a problem with them? Is there a known vulnerability in a component that I have in my application? Right? So CVEs, common vulnerabilities, and there's a database maintained by the US government and many people contribute to. I think there's more than one or two databases that you can use to go and look and see whether the component you have has what's the severity of the vulnerability I have. So let me, and this is the screenshot of the page, and I'll show you this later. But let's go and take a look at this in a second. There's lots of commercial products, so I'm not talking about products specifically here. There's lots of things that will do CV detection given an SBOM. Commercial, open source, most of the cloud providers provide something. They'll scan your container images and tell you, are you worried about anything that's in there, right? And they're basically using an SBOM to do that. So let me try switching over to a shell and see how well we do. Okay, I can make that bigger, a bit bigger. Okay, so I've got Spring Pet Clinic here. I'm going to just go over there. Spring Pet Clinic. I just downloaded this, right? So I did a git clone. I cloned a certain tag of the Spring Pet Clinic, and I added that plugin to the POM. And it's actually a large POM. That's only 4%. So let me just search for this thing here, Cyclone. Okay, so this is exactly what I had in the slide. I just pasted this into the POM. Okay, and now I'm going to do a build with Spring Pet Clinic. So I'll do a Maven package, and I'm going to skip test to hurry it up. All right. Okay, so usual build goes, you'll see at the very end here, we'll see a little statement from CycloneDX has activated the plugin. And you see here it says it found 88 components, and it's generated this file here. So let's go take a look at that file. It's in the target. Okay, so this is in CycloneDX's format. It's a rather verbose JSON file, as they always are. I'm going to jump down. It basically tells you this is CycloneDX, this is the format, and then it'll list all the components, and it'll list a lot of details about those components. This is all generated by that plugin, right? And what's happened is it's looked at the jars in your dependencies from Maven or Gradle, and it's gone through the metainf, looked for the manifest, and extracted things like the version number. So, for example, there's a log back in here. So it's found, for example, in that Spring Pet Clinic, they're using logback classic 1411. It's in there, right? So there's a full list of what's available inside of your application. So I've got this SBOM. I can also use SIFT to sort of try and reverse engineer this. So if I just, I'm in here, let me just pop up one level here. If I run SIFT, and I've just installed it, you can get this, you can go Google this, you can pull down with a bash pipe, curl bash pipe, SIFT the Spring Pet Clinic. SIFT would be good. You can't type standing up. This is my common experience. All right. Oh my God. SIFT. All right. So it's basically digging through the files, right? So this thing went off and went digging through the application, through the Spring Pet Clinic. It identified, for example, here's that logback classic. It's 1411. It knows it's a Java archive. If I were scanning a container image, it would say things like Debian package or RPM. It finds executables. It'll tell me all that. So I can get a list of what's in there. Right? Now, what I can do is, one thing is, I'm not going to talk about this today so much because I'm not really worried about the vulnerabilities. But just to map this to vulnerabilities, I can run something called gripe, for example, which is was listed on that slide of possible tools. Anchor provides gripe, and they have an open source version. So if I run gripe, and I run it on that Spring Pet Clinic SBOM, for example, it's going to go and take that SBOM, it's going to run it against the NIST database, and maybe I'll shrink this down for this time here. You can see here they're produced a list of concerns. So it took the SBOM, checked the database, and said, yeah, you've got a bunch of things. Look, that logback classic 1411, it has a vulnerability. It's a high vulnerability. Actually, I'm going to rerun this and generate a different format just to get it. It's actually pretty fast here. New version available. Oh, I lost my network? Am I? Spring, oh gosh, I've deleted it. Thank you for the pair programming. More of this, please, because obviously I can't type. Okay, great. So it just gave me a different vulnerability. So this is what you get. I can take this vulnerability, right? And if you want to know more about this, you go to that website and you type it in, and I put exact match, and it will slowly find it for me. It says a serialization vulnerability and logback receiver component gets blah, 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 denial of service attack. So you can learn more about these CVEs. So I'm not going to focus on the CVEs, but there's a tool chain that you can assemble to get reports on how vulnerable you have, how dangerous are the vulnerabilities you have in your application. The main issue here is SBOMs, right? What's in your application? Key question. So I'm going to use SIFT as a way to determine how much stuff I've got, right? By looking at the SBOM. So I'm not going to focus on the cloud, or most of these applications. Most of the components we can talk about hardening. In the application code, hardening is a bit of a trickier topic. You should have obviously less code, but applications have their own types of vulnerabilities that you may introduce through coding practices. So tomorrow, Brian is going to talk about some secure coding practices that'll help you with that part of it. But we'll see a little bit later in this talk about some of the things we can do to improve we can harden the application, but it's a little bit, nothing you can do directly exactly. In terms of application dependencies, obviously hardening means have less. It's very simple. Reduce your dependencies, right? So don't bring in everything, right? If you don't need a library, don't use it. My boss likes to say, "Oh yeah, you wanted a cup holder and you imported like a car, right? Like all you wanted was the cup holder, but you brought in too much stuff." So be careful with that. And then some advice from SHAUN from Spring. He's like, "You need to upgrade, like get the latest version. You know, all the tests and all the code coverage in the world doesn't help you if the things you're testing and working with have vulnerabilities, right? So get the latest version." This is just general advice. So the JDK and the JVM, the same advice applies. Right? So every quarter or so, Oracle releases patch set updates, CPUs, for the JDK, the JDKs that are supported. And you'll see here that the GraalVM and the Java SE schedules are the same schedule because we are built on the same core. GraalVM is built on Oracle JDK. And you'll see that there's like 2502, 2100, all these different versions. Every quarter they come out. So if you're using 17, get the latest 17. When those CPUs are published, we announce people can figure out what was fixed, and they'll know there's vulnerabilities in previous versions they could exploit. So the moment a new CPU comes out, it's almost like we've told them what the bugs were in the previous versions you need to be careful with. So always upgrade, right? And that's a large surface area, right? Like 4,000 classes, a lot of C++ code, like I said, compilers, garbage collectors, and so on. It's worth staying current. Okay, but let's move on to the meat of this. So I'm not going to talk about cloud because I really have no control over the cloud. I'm focusing on Java, and I'm going to use Docker as a way for me to put a box around the environment. So the operating system that's inside of a Docker container, I can control that, right? So the topic here is Java and Docker. How can I harden this package? So I need an example. I'm going to use JWebServer. Has anyone seen JWebServer before? Yeah, it came in Java 18. It's a kind of useful utility. It's Java code. There's a module in the JDK. It just serves static pages, and there's a convenient little utility. Like they actually have JWebServer binary. All it does is boot like Java minus blah 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 with the modules, and it runs this thing. And I like it because for demos, it's built into the JDK, so I can show you some Java code, not have to write any Java code. And you saw how my typing was, which was really bad. So I'm not going to do that. So let me just show you JWebServer. It's not super exciting, but it's interesting nonetheless. So let's just go to a folder I have here. Okay, so I'm going to run JWebServer. It's on my class path. It's just in the JDK. So if you install any JDK after 18, JWebServer is there. I'm going to background it. So it says, hey, I'm serving up all the files in this folder and subdirectories on port 8000. So here's the URL for that. So I can just take that and I can curl it. Curl. You can just see this thing does, right? It serves up, if it finds an index.html file, which I happen to have in there, it serves it up. It's kind of scary because it serves up everything, like, you know, some shell file I've got, it serves it up. So this is for dev test, obviously. But it's a nice little utility because it's just there, and you can, if you're doing some testing with your Java app against HTTP servers, you've got a little one. Right? So we're going to use that for our sample. That's what it is. Okay, so everyone familiar with Docker files? Who's not? Who can't read a Docker file? A lot of Docker files coming. So if I'm going to put a Java application in a Docker file, deploy in Docker, people typically, well, this might be the most commonly used method, I hope not. You go grab a Slim container image like Debian 12 Slim or Ubuntu, download and install a JDK, and then, like, you know, copy in your app and run. This is basically just get me an OS image, copy in the JDK. This works, right? So JWeb server is built into the JDK. This is GraalVM 21, but same thing. The process is download the application, copy in the index file, and then run. That's all we're ever going to do in this application, right? Copy the index file and run. This is 785 megabytes, right? Which is pretty huge. The question is how much stuff is in there, right? What do I get for 785 megabytes? So I run Sift on it, right? That tool I showed you. And so Sift says you've got 103 packages. Now packages can be, like I said, in this case, Debian packages, like OS packages. It can be Java archives. It has 2,900 files and 779 executables. Now executables can be shared libraries or binaries, executables. That's a lot of stuff, right? All I'm doing is running a little binary, and I brought in 700 executables. And I wasn't thinking about it, right? I just said, yeah, give me Debian, give me a JDK. It's kind of scary if you think about all the artifacts which could possibly be vulnerable to attack. So the next thing you might say is, well, I'll go get a container image that contains a JDK. And I just randomly picked, honestly, Eclipse Temurin. Oracle has a JDK image for GraalVM, for lots of JDK images. This is nice in that you just say, from Eclipse Temurin 21, add the index file, run JWeb server. This is 436 megabytes, which is half the size, pretty much. Suddenly, I mean, this is the same functionality as I wanted, right? I have the JVM, full JVM in here. It's half the size, and it works the same. And if I run Sift on that, the numbers don't look that great. So let me chart this. Okay, so can anyone, hope you can see this in the back? I'm going to have more of this chart. There's a lot of charts in this talk, okay? Because we're going to compare a lot of data. So if you look at this chart, it's multidimensional. Each of the rows is for the, well, in this case here. So this row here is Debian Slim. We saw that. It had 103 packages. 785 is the size, executables, and then we have the number of files. What's weird is that the Eclipse Temurin has more files. And I was actually surprised to say, oh yeah, I'm getting a thing that's half the size, but there's more stuff in it. I don't know what that stuff is. It's quite a lot larger. So honestly, going from to Eclipse Temurin pre-baked image doesn't look that better. In fact, it looks kind of worse in terms of number of executables. This isn't great. So let me introduce the concept of distroless images. And there's a number of projects out there which are trying to build minimal container images, just enough to run your application, right? Because clearly in those 2 container images I saw, there's way more than I need. I just want to run my binary, right? I'm running JWeb server. Well, actually, I'm running Java minus whatever. I don't need that much. So distroless is a project from Google. They're publishing these into GitHub. And these things contain no shells, no package managers. Basically, you can copy your stuff into the container and run it. You can't install more, which is great. So people can't, SSH into your container and then install some packages that are vulnerable and then exploit them. Can't happen, right? That's the intent anyway. And it turns out they actually create a whole bunch of these. So there's some for Node, there's some for Python. They're trying to produce these little container images that contain just enough to run the runtime that you want to run. Like I say, there are others. Red Hat has some container images and others do, but we're going to look at distroless because it has a nice set. So really, most of them I don't care about for Java. I just care about these 4. And you'll see them as we go forward through this. But the first one we'll start with is Java 17. In fact, we'll use Java 21. but they didn't have it on the website. It's there, but it's not on the website I took the screenshot from. It's a full JDK, so this is like Eclipse Temurin. It's basically it's Debian with JDK, and from there they go down and they take out more and more stuff, and they get smaller and smaller and have fewer and fewer things to be worried about. So this is the same container image or Docker file as before, but I've changed the from. So now I'm pulling from the distro image. It's 192 megabytes. It's exactly the same functionally from my perspective, but I've again halved the size, right? I've cut the footprint in half in terms of megabytes, and Sift gives me a report that there are 20 packages, which is a lot fewer, still quite a few files at 1,300, and still 333 executables. And it looks like this thing's supposed to be just Java and nothing else, but it contains a ton of stuff. So if I chart that, you can sort of see it too. On the back purple there, the number of files went off dramatically. Executables is dropping, size is down, everything's looking good. This is trending the right way, right? So I basically got less to worry about. So in terms of the hardening aspect, right, I want to have less stuff because packages are installed in your OS, they can have vulnerabilities, you've got to patch things. I just don't want to do that. I want to get this down to the smallest possible size I can. So, what happened there? So what can we do? Next step is to let's work on the JDK. So I've shrunk the OS down a little bit at this point. The JDK itself, I can shrink down what I'm deploying. So has anyone used Jlink? Okay, a couple of people, not much. This is not surprising. It's been there since JDK 9, and it's designed to help you produce what we used to call a JRE. Now they're just calling it an image. It's an overloaded term. That just contains the JDK with the modules your application needs, right? So if you look at the module, set of modules in the JDK, I'm not sure which version of the JDK modules these are. Jlink's purpose is to let you say, I want to build a custom runtime for my app, and I want to include certain modules so you can basically get rid of all these modules, right? So again, from my hardening perspective, I'm going to chuck out stuff I don't need, right? So that sounds pretty good. And so what's nice about that is, from a distillers perspective, these distillers guys have a team have a base image that's designed to run Java apps. It doesn't contain Java. It just contains the shared libraries and other things you would need to run the JVM on it. So it's convenient for Jlinked applications. You run Jlink, and I'll show you this, and then you copy it in, and it'll run your application. So it's a bit more complicated. Right, so if I show you this here, I'm going to go get a JDK. In this case, I'm going to again get GraalVM, but you can get something else. Get JDK 21, and here's the Jlink command, which says, here are the modules in the JDK. I want this module. So I've got jdk.http server. That's where I happen to know that JWeb server lives. That's the module. And I've done a bit of work to make this compact. So I don't want a lot of stuff. So I'm stripping all the debug information out. I'm compressing it to make it small. All the header files are gone. Man pages are stripped. Right, everything is out. I'm stripping everything I can as part of this Jlink, and I'm going to put it in. The output will be put into a folder called jweb server or jwebserver.jlink. So why don't I just show you that? Oh, sorry. And then I copy the output folder into my runtime image, base image here, and run as before. So again, I'm just building a folder full of my custom JVM and copying it over. So let's go look at that. Oops, that's not right. That's not right either. Let's do it this way. Okay. Okay, it's good. So I've got many Docker files here. I'm going to cat one that we were just looking at, so I can just run it on the host so you can see what it does. So here's that same one I just had in the slide. So I'm going to run this for you, not in Docker, just run it here. Okay, so it runs. You see here, it's figuring out which modules you need. So I needed JDK HTTP server. It's figured out I need Java base, right, because it's dependency, and it's done. If you see, it's created a folder here, JWeb server Jlink. Its size is 91 megs, which is pretty good because the JDK itself is at least twice that size. So it has gone down significantly in terms of size. So that's pretty good. So it's a smaller footprint for sure. So if I go back over to my slides, there we go. So if I then take a look at the container I build, so it's just the Java base with Jlink, the numbers have gone down a bit, so fewer packages. So that the Java base thing designed to run just Java applications is not that much smaller, honestly. Let's chart it. Number of files kind of the same. Number of executables kind of the same. It's smaller, more packages. I'm making some progress. So I've shrunk the JDK to have less in it, but somehow I still have a lot of stuff in here. So what do I do now? So I've shrunk the operating system. I've shrunk the Java footprint. What do I do now? Right? What can I do better? So the next step would be to use GraalVM Native Image to ahead of time compile your Java app to make it even smaller, right? To throw out even more stuff. So if you've not used, anyone use Native Image? Okay, you have, but I know that. Okay, so what we do is take GraalVM has the Graal compiler. We can run it ahead of time instead of running it just in time, right? So rather than JIT, it's AOT. So at build time, you take your jars, class files, you run them through Native Image, it spits out a binary for Windows, Mac, or Linux, depending on which platform you're on. And I'm not going to go into huge details here. Let me just show you quickly running it and give you some pointers. So that worked that time. So I'm going to just do it here so you can see it. I got a Docker file. Which one do I want? I want that one, just so you can see the command here. So here's the command to run native image. This is saying native image, minimal optimization because I'm in a hurry. Don't spend some time on that. Nice feature is that native image will let you generate, like you saw before, for an application that's compiled. It'll actually generate and embed an SBOM in the binary. So if someone, I can get to this, but basically it's available to sift. I want to package up that module, and I want to produce a binary called JWeb Server Dynamics. Let me just run this thing. This runs in about 20 seconds. That did not work. Okay. This is on a cloud machine. I plugged in for like Ethernet to make sure I didn't lose it. So why this is interesting from a hardening perspective is what it does. So native image, it will go through and do a static analysis of the application. So JWeb Server, it's looked at the entry points. It's done analysis of all the classes it can get to. It's going to generate a binary that contains only the classes that it can statically identify as necessary. But more than that, it actually is a bit more aggressive. So if you look here at this little output, it says that of the total classes on the class path, only 75% are needed. So 25% of the classes are not used by the application. In terms of fields and methods, in this case, 50% of the methods that it finds in the class path are not used. So what happens is native image generates an application, a binary. It doesn't generate code for the methods not used, right? So I'm basically throwing out 50% of the code right now when I build this application. And other things go on, but that's basically the gist of it. And just so you can see this, LH here, that dynamic web server is 15 megabytes, and I LDD that just to show you what it is. It's JWeb server. It's an executable. It's a Linux executable with a bunch of shared libraries it requires to run, right? So I can run it. And it's just JWeb server again, right? So that module compiled. I won't look at all the details here because there's more to talk about native image. I won't do it because Alina in the front row will give you a talk, and I'll give you a pointer in a second. I did want to show you something bigger though, so I just sort of on the side, here's Spring Pet Clinic, which is a much bigger application. Here's the output from native image. More of the code is on the class path, so 93% is actually reachable, which is interesting. But again, about 35% of the actual methods code are not used, so they're discarded. So if this were my little sort of circles of my application, right, the JDK, I should point out classes means also JDK and dependent libraries and your code in a typical application. Native image basically is taking out, chopping off a whole chunk of it, right? It's just not in your application. So this is a pretty good approach. When you realize that's 109,000 methods in Spring that are being discarded because they're not used, that's a lot of methods. That's a lot of code. That's a lot of potential vulnerabilities, right? So this is a good hardening approach. Okay, so native image has a whole bunch of features. I don't think we have a lot of time to go into them, but the idea is we only include the classes, methods, and fields that you need. Everything else is gone. So you're definitely reducing it, right? There's a lot of stuff around how it's built. Like if you have files you're loading, only files you tell us in advance, like resources, are included. So you can't have pick up a file off the file system that maybe someone placed there by mistake. There's no JIT compiler, so we can't load the jar file and then discover some new code at runtime. Basically, you've got a sealed, closed world, so you're much less vulnerable to a number of attacks like deserialization attacks, which I'm sure that Brian will talk about in his talk, which is one of the most well-known attacks for Java is deserialization attacks. There's all kinds of things. For example, the GC. So you have a number of GCs in Java. Only the garbage collection algorithm that you use is actually included in the binary. So, in Hotspot, you've got G1, ZGC, generational ZGC, serial, parallel, all those things. Only one of them is going to make it in the binary. Again, shrinking the attack surface area, right? We're hardening our application. And there's all kinds that goes on. So, and also just, this is the quick plug. It starts really fast. Quarkus and Heldon gives some numbers about like way less memory required. So there's all kinds of great stuff. Alina in the front row here will give a talk on Friday where you can learn more. We're going to move on. So I'm shrinking, right? So I built this little binary. I'm going to stick it now. I'm going to deploy it. So it's a Java app. So I'm going to put it on the same Java base as Jlink as before, right? So it's really, let me see here. And how this works is that distroless Java base image contains all the libraries, all the shared libraries you need for your application. So when I compiled that application, you saw me go LDD. All that stuff you saw at the bottom is below the orange line. That's what the container, my environment, needs to give me for my app to run. So this is why this is sort of working. That Java base has the libraries that you need for this, just for any Java application, including the dynamically linked one. So it looks a little bit different now than before. I'm going to go get a JDK. In this case, I'm going to get the GraalVM Native Image JDK, or the JDK with Native Image. I'm going to run that build command you saw, and then I'm going to copy the binary here, copy the binary over into my runtime environment and boot it. So the bottom is always pretty much the same, except in this case it's multi-stage build. Now, that's only 48.3 megabytes, so that's getting down there. It's pretty good. We saw the binary itself was 15, right? We did see this. It was only 15. If you run sift on it to get a report, it doesn't look great, honestly. So I did all this great work on Native Image to make this thing smaller. I spent all this time. And in terms of the number of components I'm still exposed to or exposing to the world, it's still quite large. And it's really because of the OS, right? I've got way too much operating system for my application. Operating system or components from the operating system, I honestly don't need. So we just saw this, right? This version where I compiled the application and it has everything is dynamically linked. But with Native Image, I have other options. I can do what we call mostly static, where I say, give me a binary and include all my dependent libraries except for libc. And that's not a bad solution because it means that I don't need to, my environment only needs to provide libc to me. And that's a common thing. In fact, the distroless has distroless base. It contains Debian with basically libc. That's pretty much all in there. It's designed for this kind of thing. So a lot of applications you'll get will be linked this way. What's nice about this is that, what's good about it is I'm still dynamically linking glibc. Do not statically link glibc. It doesn't work, is the first thing. You'll get a seg fault pretty quick if you try this. And also, it's GPL. So if you statically link in a GPL library, then you're infecting your code with GPL. So that's obviously bad. But it's smaller. You'll notice the full thing is smaller. And the final option I have is a fully statically linked image, where I take all the shared libraries, I statically link them into one binary, right? So and then it turns out that I don't need anything much from the operating system environment, right? So there's an environment here, or a container image from distros called distro static. It's got a few things in there, like certificates, a few things in real applications need, but does not contain any libraries, right? It's just your application. And that I can get to 17.1 megabytes in terms of the container image. And what's different, I mentioned the licensing here. So muscle libc, which we use for static, is MIT licensed. So it's safe to link into your code, doesn't infect your code with any nasty license concerns, and it's more compact. And so we use muscle. So it's quite interesting how I can link the application differently and reduce my dependency on the operating system environment. So if I chart all those, what's crazy on the far right-hand side now, distro static has one executable, right? My application. This is good. This is what I want, right? Compared to the first, we started off with 778 executables / shared libraries. It's not very big. There's still a whole bunch of files in there because Depending on your application, you may need, like I mentioned, certificates and different things for your application to work and connect to other services. If you don't need all those services, you may not need all these files, but there's not very much in here. This is looking pretty good. Now, a lot of people wonder, like, what about Alpine, right? Like, Alpine's great. Everyone likes Alpine. So I did build with Alpine. Same idea. I took a fully statically linked image, so I didn't depend on much from Alpine. I went and copied, so I got Alpine 3, I copied the binary in there, and that's what I built. It's 21.9 meg, a little bit bigger. These numbers here look pretty good. 80 files, 18 executables, strange, 21 packages. So if I chart it, Alpine looks pretty good, actually. The only thing is, all the distroless container images have no shell, right? And if you know Alpine, Alpine contains BusyBox. It's built on BusyBox. Rather than having bash and cp and move and all these separate Linux processes, they're all one binary. So they have one binary that does everything. It's BusyBox. And it's still in there. And I was reading articles about how can I take BusyBox and remove the shell component or disable shell. It seems like you're swimming upstream. You're basically, this is not the intent of Alpine. It's a full OS. I kind of don't want a full OS. I want just enough OS to run my application. So this is pretty cool, but it looks small, but there's some negatives here for sure. So we're going to go down to the very bottom. Anyone know Scratch? Anyone ever use Scratch? Yeah? So Scratch is like the bedrock of Docker. So if you go and get a Docker file off of Docker Hub, if you look at the definition, if you work your way through from like one's built on another, you go all the way to the end, you get to Scratch. And the first, like Debian lowest level will say from Scratch. And Scratch has nothing in it. It's like the root object. It's like null, starting from null. And as you see from the official web page, right, this is designed, really, even though it's useful as a base for other ones, designed to run a single binary that contains whatever, and that includes whatever it needs. So since there's nothing in there, you better put everything you need in this Scratch image. It turns out, though, that I need two things. I need my fully statically linked binary and the index file or whatever files I wanted to share out, right, in my example. So the container build is exactly like the previous two. It's the same as for Alpine, same as for the static base one or the base one. It's build the executable, copy it into Scratch from Scratch. There you go, right? And it turns out it works exactly the same. So this has a really good SIFT report. So SIFT is telling me in the container image, right? So it scans the Docker container image. It finds 6 packages, 1 executable. And it turns out the 6 packages are actually all the same thing. They're all the native binary. So the native binary, when you compile native image, I mentioned that I had enabled SBOM embedding. So when I say minus SBOM enabled, the native image will actually produce an SBOM embedded inside of itself that can be extracted by SIFT or for other tools. And we actually contributed to SIFT the code required. So when SIFT runs, it runs around looking at all the files and tries to figure out what they are, and then has algorithms for extracting the SBOM. The GraalVM team contributed, they call it I can't remember what they call it now. There's a phrase for what they call this thing. Basically, the plugin for SIFT that says, oh, this is a native executable. This is what I do to extract the XBOM. So what you see here, these 6 packages are things like JDK HTTP web server that we saw the module for, some components from GraalVM itself, but basically they're all just part of the binary. The only thing in this image is basically 2 things. So this looks really good. I have 1 file. Actually, I have 2 files because the indexed HTML isn't being counted. That's very suspicious. There's 2 files in there. 1 binary, it's about 15 megs, and the 6 packages are all the things that I know are in the native executable. So let's, just for fun, I'm going to run this thing. Okay, network is still there. Let's see here. So I've got Docker images. So I built a bunch of them, right? So I got a lot of these. Let's just shrink it down to fit. So these are weird. So these are all the exact same application, right? Some of them you saw, some of them I haven't done demoed here. But the sizes are crazy all over the place, and they're all basically functionally equivalent. So the story here is, you need to make some choices. Like, what do you need? You can look at your application. You can look at its requirements. You can pick out the right container image that just contains enough operating system to run it. Clearly, the Debian, distroless Java here is pretty good. That was where we started with Debian. It was huge. There's one here I didn't show, which was Scratch. This is a bit of a trick. I can take that binary and I can use UPX to compress it. So if you want to get a really, really tiny container, right? It's a 4 megabyte container image, and it runs the same application, and it unzips at runtime. It's not fast. It's cute. But where's the small one? 21 Alpine static. Where's Scratch static? 13. So I can run it, right? Docker run minus D for background. And I want to run, oh, I'm going to not forget the port mapping. So it's port 8000, and it is JWeb server colon Scratch static. Okay, and I can curl localhost 8000. Right, so it serves up that index file that I copied in there. What's cool is, if I try this with something else, remember that clean.sh file there that I had? Of course, it says file not found because that container image, I didn't copy it in. So I'm only seeing what's in the container image. So this is working. Again, it's 15 megabytes, right, which is kind of crazy. So I'll be nice. Now, there's a whole bunch of Docker best practices that I am not following. So don't that wasn't the point of the talk today. So, signal handlers, SNCC, Brian Vermeer has written on this, and there's a nice cheat sheet on things you should do to do good hygiene for Docker. Like don't do from image tag, because you should use a digest and all this kind of stuff to lock it all down. But for our purposes, it's not too important, right? It's demo. All right. It's going to stop. Okay, so let's go back. Let's just review where we were, right? So we started off with this huge surface area of concern, right? Application code, dependencies. Yeah, 88 in the Spring Pet Client is kind of scary, but even that isn't the worst. JDK, JVM, operating system, cloud, all these things are a concern. What we did was I used Jlink to basically shrink down the JDK classes. I removed JDK classes to reduce it. So I hardened the JDK itself by taking out pieces I didn't need. I used minimal container images to, again, throw out more stuff I don't need to shrink that down. But I got stuck, right? I got stuck at the point in the sense of the JVM itself. I couldn't really reduce that size. And then I used Native Image, GraalVM Native Image, to essentially replace the JVM, or only use the pieces of the JVM I needed at runtime, and only the classes and dependency code and JDK code that I needed to run the application. So it's a lot smaller, and I hope my visualization is working. It worked in my mind. So just to sum it up, there's a few things that are hardening, and some things that are just good best practice. So reducing your third-party dependencies, right? The first thing you can do, the Marie Kondo thing, is throw out whatever you don't need, right? So that's the first step to do. You should try using SBOMs. So try the Cyclone DX thing, try Sift. It's really interesting to let you introspect what you're doing, even for things that people are giving you. It's good to know what you've got. Now, one thing I didn't mention, I have a couple minutes, is that certain things, the SBOM tells you which packages are installed. In Native Image, we actually produce a file that tells you every single method and class that's actually being used in there. And at Oracle, we actually have some tooling we're working on that will let you actually determine whether, yes, you're using log4j whatever, and there's a known vulnerability, except it turns out that the method that contains the vulnerability is not in your application because we threw it out. So you can know, for example, like, oh, this new highly critical, very scary CVE was reported, but don't panic. You aren't vulnerable because you didn't actually have it in your app, even though you were using that module. So that's a really interesting feature we can do with Native Image. So anyway, SBOMs are really interesting and really cool, and really can help you in terms of understanding what you're doing, what your suppliers are giving you. We saw use of Jlink. You can use Jlink with your regular apps. There's an additional tool as part of the tool set called JDEPS. It'll help you take your given application and figure out which modules you need. I don't know how great this is, honestly, because I've seen people trying to Jlink the Pet Clinic. And I noticed that the Spring guys don't have a Jlink version of Pet Clinic, and I've seen people trying to put together in their spare time, like on GitHub, like, oh, here's my attempt at Jlink. So obviously it's not so straightforward to just pick up the module system. So your mileage may vary on whether this works for you or not. Number 4, upgrade, right? Stay clean, get the latest stuff. Small container images, and then the final thing you can do is just shrink the application down to its absolute minimum size using GraalVM Native Image. And I should say you can get it at graalvm.org. I didn't tell you where you can get it from. All right, so that's all I have for you. Thanks very much, and I guess we can take some questions. There's a microphone. Oh, we have a mic. Up front. Oh, sorry, we're turning it on. Nope.
No? Never mind, I'll talk now.
They want to get you on the recording.
I can repeat it, though.
Oh, I can repeat it. I can repeat your question. Go ahead.
Have you compared the images you've done with something that build packs has done, using some
If I compared with build packs, same thing should apply. I mean, it's just Docker container images, right? So you should be able to construct it. I don't know whether we have a build pack for native image. Yeah, we do. Well, there's 2 actually. Well, there's 3. I don't know. There was one that was Bellsoft had put one out with native image. We put one out with full Oracle GraalVM with different versions. I guess that's the 2. There's an ARM one that came out recently, so ARM support. So there are build packs, but that's just for the compilation part. After that, you've got to decide what your final target deployment is. I'm sure the build packs let you decide what your final output is. I know that I've used Micronaut has support for actually compiling and generating a Docker file, even pushing a Docker file as part of just POM. They're using Jib for that, but I know that in the config you can go and say my final from container is this, and it'll just use it for you. So I'm sure this Spring offers the same, but the build pack should work too. Just Docker. Yeah. Yes, a question there?
Thank you for the talk. It was really great. Last time I tried out this stack, I kept running into lots and lots of issues with, when you include a library, something that you need, basic stuff like a bouncy castle library, something like that, and the native compilation starts failing, or what's sometimes even worse, that it compiles and then at runtime under certain conditions, exact faults.
Yep.
And I'm not sure if it's got better recently,
Right.
but that was kind of like my experience with the exact same.
Oops. More pictures of helmets.
Yep.
Hang on. Yeah, so, jeez. Yes, the question is with native image, it compiles what it can see, right? And so you can get into situations where, especially you're using reflection to refer to a class. It's not that bad. I watched Josh Long at Devox try to break native image with reflection, and it kept outsmarting him. I kind of figured out what he was up to. But it's certainly possible for you to have code, or usually library code, where they're doing some sort of reflective loading of a class. Because we're doing static analysis, we don't know you need that class, and so it's not in the binary. And you run the binary, and it goes, class not found, right? It's a pain. It is better than that, and I just want to go over to show you. Let's see here. We have a project that helps a lot with third-party libraries. Hang on here. So graalvm.org, and if I go over into the docs here, I can get myself to the page I want to go to, which is Libraries and Frameworks for Native Image. And so this came out of work that was done with Spring Boot 3. So Spring Boot 3 embraced native image. Out of the box, if you go Spring Initializer and create a project, you don't even have to turn on native image. The parent POM of all the projects they're generating have native support now, so you can actually use commands for Maven and Gradle. So the Micronaut team, Spring team, got together and basically captured the metadata that deals a lot of reflection for a lot of third-party libraries, especially the ones the Spring depends on, because they have lots, right? So for Spring Boot 3 to work, they needed to make sure that all the things they use work. So if you look down here, we've got a catalog of all the libraries that are basically you can use and are pre-configured. And there's a Maven and Gradle plugin we have that all Spring, Micronaut, Helidon, we're all using the same native build tools. What happens is when we compile your application, we look at your dependencies and we automatically consult this repo, which is actually on GitHub, to see if there's some metadata. So if you're using certain libraries, like let's say you're using MongoDB's Micronaut Mongo BOM thing, that's not a package. It'll automatically see whether there's metadata, right, for that and pull it down for you. So it's getting smoother, but it's really a community event, a community contribution approach where someone uses a library, goes, you know what, this library needs a little bit of an adjustment, and they contribute that back to the repo. They do a PR on the repo. So it is better, but it's not perfect yet. Yeah, and so I don't guarantee you won't hit this, but at least you're armed with some techniques to maybe reduce the pain.
Thanks a lot.
Sure. All right. I'm red. Any more? Okay, thanks very much. So if you want to talk some more, I'm going to be down at the Oracle booth today and tomorrow. Thanks very much.